Hello, everyone. Mr. Minnick's my name, math is my game, and today I'm joined by my fifth period Algebra II class. We're still in Chapter 4, Section 4. We're still looking at our intro to factoring. And this is going to be like part 2, I guess, if I had to give it a title. We're going to officially start talking about factoring tomorrow. We're going to officially start talking about factoring on tomorrow. Let me see if it likes that Roman numeral. Let's try that. It didn't like that any better. Intro to factoring part 2, as they say in France. Why do they say that? Does anybody else get offended by that in France when they say duh for 2? I find that pretty offensive, actually. Why? Because when you say duh, it's like an insult, right? Like, duh, should have known that. That's how they say too in France. What's that? That's how they get you to remember it? Could be. You know, they don't eat omelets in France because 1 egg is enough. All right, enough about France. That's so bad. That was so bad. All right. So today we're going to be talking about TLAs and the distributive property and foiling. Notice we still haven't really officially factored yet, and we're going to just scratch the surface of factoring on today. So we'll be talking about the distributive property. You'll probably learn a thing or two about it that you didn't realize. I learned something about it that I didn't realize on today, about factoring and the relationship, just by going through this little exercise. And then GCFs, we'll be talking about those. Any questions about anything before we begin? Okay, so the distributive property, it's pretty easy, pretty straightforward. Just about everybody knows it. Every time I tutor people in math, my 1-2T, he was the man. He was like a machine when it came to the distributive property. He really knew it well. The distributive property, of course, if you didn't know, it says A times B plus C is equal to something. And I probably said more than I should have during second period, but I'm going to grab my creative pen here. And some people like to think of rainbows. Some people like to think of rainbows with this. And some people actually draw out rainbows, you know, Roy G. Biv. People like to make these rainbows. It's weird. Whoop, blue rainbow. And then, well, I better make it blue. Like a blue rainbow. And then a green rainbow. So the blue rainbow, AB, I guess that's going to be AB, right? That's times B. And the green rainbow is going to be A times C. And of course, there's a plus sign in the middle. So the thing about the distributive property is that it really involves multiplying. Anytime you use the distributive property, what you're really doing is multiplying. You're just multiplying rainbows. Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. What you probably failed to realize is that the distributive property is used in foiling. Did you know that? So let's think about foiling. We said we're going to talk about the distributive property. We're also going to talk about foiling. Now, some of you didn't get to see this question. My wife did this the other day. It really made me so mad. Now, this is just going to be some rainbows, right? What's that going to be? The purple rainbow. PA, Pennsylvania, where all the men have mustaches. Did you ever notice that? When you go to Pennsylvania, every man in Pennsylvania capable of growing a mustache has one. I don't know why. One day I'll find out and I'll let you know why. Okay, so I'm going to go with pink. P, I guess that's going to be PN, right? PN. And there's addition in between these. And then what's next? Isn't L.A., isn't that where Ray Gorin's from? Cool. Los Angeles or Louisiana, depending on how you look at it. And then the last rainbow here, I'll make it gray. The gray rainbow is going to be ln. We're actually going to talk about ln in chapter 7. So my wife did that the other day, and it made me so mad. She foiled my plan. She does that a lot, actually. So again, the interesting thing about foiling, we are multiplying. We are multiplying by rainbows. We're distributing. And distributing is essentially how the foiling works. It's just with a couple more terms in it, right? Is everybody with me so far? Does this make sense? Cool. Good. Well, what you probably didn't know about the distributive property is this. You can use the distributive property to multiply large numbers. Some people do this already and they don't even know that they do it. Some people already do this. But you could use the distributive property to multiply large numbers. If you've ever sat in an advanced math class, one thing you'll notice about every single teacher in an advanced math class is they never, ever, ever, ever reach for a calculator to make calculations. Ever. And they don't do that to show off. Some are actually really poor at calculating. But let's say we had to multiply 156 by 23. That seems pretty tough to do, right? Some people use the lattice method. Most people are going to grab a calculator, though. Some people are going to say, hey, Google, or Siri, or Bixby. But you don't have to. Let's think about the number 156. True or false? 156 is really close to 150. Is that true? Okay. It's just got 6 more, right? All right. And 23, isn't that close to 20? So that's just 20 and 3 more. You picking up what I'm putting down here? Okay, so let's think about foiling. The F part, the purple rainbow, 150 times 20. You might not know 150 times 20. I don't, but I sure as heck know 15 times 2. 15 times 2 is going to be 30, and there's 2 more zeros. So what do I got to do? I got to throw in 2 more zeros. So I get 3,000 from my purple rainbow. My blue rainbow is going to be the last terms. I might not know 150 times 3, or I could just take 150 plus 150 plus 150, or 15 times 3 and add a 0, whatever it is. What's it going to be? How much is 150 times 3? Anybody? 450. So I'm going to kind of mix things up now. Watch where I put this 450. I'm going to drop it right down here. Hopefully that doesn't offend anybody. So let's look at this inner rainbow. This inner rainbow, 6 times 20? 120. And then, last but surely not least, and I know your name's not Shirley, the last product, 6 times 3, is 18. So in doing that, we still have to multiply, but we didn't have to multiply anything difficult to multiply, right? And when we add, we don't have anything real difficult to add. We just add right down the column. Down this column, we get 8. Down the next column, we get 8 again. Down the next column, we get 5 and a 3. And that's it. Did you know you could multiply big numbers like that? Maybe you did, maybe you didn't. So the distributive property can be used to multiply large numbers. That's the distributive property. It's essentially just rainbows. And there's one more thing about the distributive property. The distributive property. The distributive property can be used to do the F word. A lot of people in math think that factoring, that's the F word. It is an F word, factoring. But the distributor, the distributive, the distributive, the distributive, I-V-E. The distributive property can be used to factor. So earlier today I used an example kind of like this. I went with 5x to the 5th power minus 10x to the 4th power. Oh, come on, think, McFly. Trying to dream up a nice example, sorry. Drawing a brain fart. Maybe 120 x squared. I think that's going to do it. Hope so. Sorry. I used to be really good at coming up with these examples. Oh, dang it. I'm sorry. That x squared is supposed to be x cubed. My bad. That's a neck. I'll neck myself on record. Probably heard that on the tape. Okay, so the distributive property can be used to factor that. Now here's the problem. The distributive property looks like this. A times B plus C equals AB plus AC. So the distributive property's got some parentheses in it, right? But then again, at the end of it, it doesn't. The distributive property has parentheses in it, but at the end it doesn't. So the deal is this green stuff doesn't have parentheses, but I want to make it something that does have parentheses. In other words, we're so used to, in the English language, reading from left to right, that we take this distributive property and think, well, it can only go that way. Do you remember in geometry that one property that you hated, that you thought was the dumbest thing ever, that you'd never use, the reflexive property that says A equals A? Watch this. Flip from left to right. Did you know that arrow could go the other way? What's the distributive property? There's something called the undistributive property. The undistributive property. The distributive property. Well, it's actually not a thing, and it's not called that, but we're going to make it. We're going to unpack this and figure this out. We're going to make the undistributive property a thing. The undistributive property. If the distributive property involves multiplying, the undistributive property is going to involve what? Unmultiplying. Division. Somebody said it. Wow. So this is going to be unmultiplying. You know how long it took my second period class to come up with that? Took them a minute. So the undistributive property is going to be unmultiplying or division. So what I mean by that is if you had something like AB plus AC, you could think of it in terms of extracting an A out of both of those things. Reaching into its heart. This reminds me of Indiana Jones in the Temple of Doom. That one scene where they reach into the guy's heart and it's beating in the guy's hand. And they're all chanting, Om Nam Shivaya, Om Nam Shivaya, Om Nam Shivaya. It's pretty cool. So anyway, we're going to reach in there. We're going to pull out an A out of that. And this is going to be A times the group of B plus C. It's the exact same thing as the distributive property. It's just we're looking at it with a whole new perspective. Do you see what I'm saying here? You picking up what I'm putting down? Maybe you do, maybe you don't. The English language has got us so messed up. We're so used to reading things from left to right that we'd never look at things from right to left. It's a shame. It's really sad that we don't look at things from right to left sometimes. You know what that's called when something looks the same from left to right and right to left? Palindromes. There's a lot of palindromic numbers, right? Like 3,003. It's pretty cool. So the undistributive property is unmultiplying. So let's look at this thing. let's look at this green expression here, and let's see if we can't figure out how to unpack it, how to make it so that there's going to be some kind of parenthesis out front. Huh. So that there's something that we can extract from each of the three terms in this expression. I'm hearing somebody say a 5. So sometimes we got to look at this. We got to look at that. We got to look at that. We got to look at that. Each one of those is a term. I don't know if you guys understand what terms are yet. Chapter 5, we study polynomials, and terms are separated by addition or subtraction. So this is a term, this is a term, and this is a term. And somebody said 5. That's good. It's a good start. There's something that we haven't talked about yet today that we need to be able to go any further. The GCFs, the greatest common factor, greatest common factor. Okay. So there's a word that's synonymous with factor. Factor are those things that multiply out to be a number. There's a synonym that we could replace the word factor with that starts with the letter D. Not denominator, but that's a good try. When you factor, you're essentially looking and you're dividing the number up. Divisors, divisors, divisors. Okay? The reason I bring this up is because at some point in the near future, you're going to try to use the TI Inspire. And the TI Inspire, as good as it is, it doesn't have a command for greatest common factor. But it does have a command for the greatest common divisor. And once it loads, I'll show you. So greatest common factor, some things about them. Greatest common factors can be no larger than the smallest, I'm going to put in parentheses, smallest than the smallest term. It's kind of interesting about a GCF. A GCF isn't allowed to be any bigger than the smallest thing you got there. The greatest common factor can't be any bigger than the smallest thing you got there. So maybe it makes sense to look at some specific numbers. Find the GCF of 8 and 24. Now, a lot of people make mistakes when they do this. They say it's 24. It's not 24. It can't be. It's not allowed to be any bigger than the smallest term. They get it twisted. They don't understand what factors are. They forget the definition that their 6th grade teacher told them about factors, or that their high school algebra teacher told them about factors. If they're trying to find the LCM, they might look at 8 and say, okay, 8's multiples are 8, 16, 24, 32, 40, 48, etc. And they might look at 24 and say 24's multiples are 24, 48, etc. They might say, well, 24, that's the LCM. We're not finding an LCM. People get the LCMs and the GCFs confused all the time. Don't get it twisted. When we're trying to find the GCF, we're going to look at 8's factors. What are 8's factors? 1 and 8 and 2 and 4. Being able to find those factors of a number like that, that's a real critical skill. You got to be able to do that. 24's factors, 1 and 24. So maybe it's 1. Maybe the GCF's 1. 2 and 12 work, so maybe the GCF is now 2. 3 and 8 work, and 4 and 6 also work. So the GCF, of course, then is 8. How's everybody feel about finding a GCF of numbers? Okay. Let's look at the calculator for a second. So I want to find the GCF. Please, calculator, help me find the GCF. Do you see how it's not how it's italicized? You know what that means? It can't do it. It's not ready. But what we said factors, and what else is synonymous with it? Divisors, the GCD of 8 and 24, and there it is. It's 8. So maybe we better try a couple more of these. And maybe I better take a picture of that and put it on here. Send to the current page. There we go. Are there any questions before we look at a couple more GCDs or GCFs? Maybe this next example will clear up any questions you might have. Find the GCF of 16, 36, and 428. Now, 16 to 36 wouldn't have been bad. I just had to go and throw 428 into the mix, didn't I? Oh, man. Maybe I could use a calculator. I got it up and ready. I got the calculator up and ready. GCD of, what was it? 16, 36? 16, 36, and 428. Oh, I can't do it. Or can it? It can. You got to do what? In the parentheses, I put another GCD, right? GCD there. Oh, yeah, that's going to work. That's going to get it done. But let's see if we can find this by hand. 16's factors, 1 and 16, 2 and 8, 4 and 4. We know the GCD can't be any bigger than 16, right? Okay. Well, let's look at 36's factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So looks like it's probably going to be 4, but I don't know if 428 is divisible by 4, or do I? I do, because 28 is divisible by 4, so 428 is divisible by 4. But anyway, we can see. So this is 1 and 428, 2 and 214. Is this divisible by 3? No, not by 3. 4 and 107. So I guess it is going to be 4 then, right? 4. It is going to be 4. It is going to be the number 4. Cool. How's everybody doing so far, okay? Questions? All right, so let's go back and look at this one that we started then. Somebody mentioned a 5 here, right? 5's an excellent start, because if we're looking at 5, 10, and 120, 5 is the greatest common factor of just the numbers. However, we got terms with variables. So let's look at variable term GCFs. Let's see if we can't figure out a few of these. Variable term GCFs. So let's look at 3x to the 4th and 6x squared. Let's see if we can't figure out the GCF of those. Now, you might have noticed which calculator I got out. Did you notice which calculator I got out? I got out the Inspire CAS. So it should be able to find the greatest common divisor of variables for me, because it'll work with variables. 3x to the 4th, 3x to the 4th, and 6x to the squared. But it didn't. But it can. It can. When we find a GCD, it's one of the factors, right? If I tell this thing to factor 3x to the 4th, suppose it's 3x to the 4th plus 6x squared. You see what I did here? I'm sneaking in through the window. The calculator can't do the GCD, but I'm sneaking in through the window. You see what the GCD is? It's going to be that part right there, right? So the answer to this is 3x squared. But you're probably wondering, well, how the heck do I find that? I'm not good at this. I don't understand. you remember when I asked you to do the prime factorization the other day ago? Yesterday, remember that? Let's break each number down into its prime factors. What's the prime factors of 3? I guess it's just 3, isn't it? And let's expand. There was this really goofy video, horribly acted. There was this guy on there, and he sounded like he missed the days where they handed out all the brain cells. Let's just leave it at that. And he talks, he says, need a hand? Expand. So anyway, he kept saying it over and over, and it stuck with me. X to the 4th is x, 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 x. Like that, right? Okay. Let's look at this next term then. This 6x squared. 6 breaks down into 2 times 3, doesn't it? And then x squared is going to be xx. So when we find a greatest common factor, we're looking for as much stuff as we can possibly find in common between the two things. So it looks like both of them have a 3 in them. Whoop, I said a 3 in them. Both of them have a 3 in them, don't they? And what else do both of them have in them? On x. On x. Just an x or an x? Well, this one has x to the 4th. Does this one have x to the 4th in it? No, so this has x squared in it, and so does this. So do you see where our answer comes from now that it ends up being 3x squared? Okay, so our answer is 3x squared, because that's all the stuff that they have in common. Because that's all the stuff that they have in common. This is a really difficult concept. If you can get this, you got 1/3 of factoring. You can put a big check in a box. This is probably one of the top 3 most important things of factoring, is being able to find a GCF. Let's try another one. Let's try 16x to the 5th y and 30x squared y cubed. So again, if you're not sure with the numbers, break it down into its prime factors. 16's 2 times 2 times 2 times 2. X to the 5th, x, 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 x at y. And then 30 is going to be 2 times 3, that's 6, times 5, right? 2 times 3 times 5. And then x squared is x, x. Y cubed is y, y, y. So what's my answer? What's my GCF? What's the most stuff that these things have in common? 2x. So a 2, we can all agree on the 2, right? Okay. And then you said something about two x's. This one's got 2 x's in it, or x squared as it is, right? So that's going to be x squared. So x squared, and what else? AY. AY, just one of them, or y to the 1st. So 2x squared y is our GCF. What do you think? Now I want to take this one step further. We're almost done today, by the way. You guys are doing awesome. This is called just finding the GCF. Find the GCF. This is when we just find it. Okay? One thing that I neglect to do sometimes, I get so overwhelmed with emotion with this when it starts making sense. I forget to write the directions. It's real important that you understand the directions. Sometimes you just have to find the GCF, but we're going to take it one step further. We're going to introduce the F word. We're going to find the GCF and factor it out, and factor it out, and factor it out. That's taking it one step further. And I know for some of you, this is like, you already know how to do this, fine. But I really want to make sure that every facet of factoring along the way, that everybody gets it. So suppose we have something that looks like this. Negative 12 x cubed y to the 4th minus 36 x squared y squared plus 6 x cubed y cubed. My other class, I didn't throw a negative out front. I really don't like negatives out front. I like to factor those out. So I'd factor out a negative. So the first thing we're going to be doing is finding the GCF. So let's see, this is negative 2 times 2. That's 4 times 3, x, 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 y, 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 y. All right, that's the first term. Everybody agree with that? Do you see how I expanded that first term out? It's really cool if you do that. Something awesome happens. The next term then is going to have a minus in it. 36, that's 6 times 6. That's going to be what? 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. And then x, x, y, y. Okay? And then plus 2 times 3, x, 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 y, y, y. I think having it expanded out like that makes this really foolproof. A foolproof way of finding the GCF. And when you go to factor it out, it's going to make it that much easier. So what's our GCF? Our GCF is what? It's not just 2. We can do better than 2. There's a 2, there's a 2, there's a 2. They all got a 2 in them. They all got a 3 in them. There's a 3, there's a 3, there's a 3. Keep going. So we got x squared, whoop, x squared, x squared. What else? Y squared, y squared, y squared, y squared. So our GCF collectively then, and can we factor out that negative? Would you mind? Let's factor out the negative. So it's going to be negative 2 times 3 times x times x times y times y. Let's clean that up. This is varsity math, son. What is that? Negative 6x squared, y squared. That's our GCF. Well, watch what happens when we factor it out. When we factor it out, what's going to happen? I want a color that I haven't used yet. Maybe I'll use gray. When I factor this thing out, what's going to happen is that GCF is going to just sit out front. Negative 6x squared, y squared. It's just going to sit out front. And what I'm going to do is all the terms that I used, all the stuff that I factored out, this minus 2, this 3x squared, I'm just going to kind of cover all that up. Do you see why I did what I did? Do you see why I did what I did? Do you see what's left? What's left is what's going to go in these parentheses. 2x y to the 4th, and then what? Minus 6, and then what? I think there's an x. I think there's an x and there's a y left, isn't there? Plus xy. Why is there a what? Y to the 4th. Oh, thank you. Good looking out. Right on. Y. This should be y squared. Thank you. Thank you very much. I'm sorry. Y squared. Thank you. Good. Awesome. Good. Now it makes more sense. Thank you. I forgot to cover these up. Okay. I forgot to cover those up. That's what it was. I forgot to cover them up. There's still 3 y's left? Where? 2 in the green and 1 in the black? The blue ones are all gone. There's 1 black one left, right? I just forgot to cover them up. What do you think of finding the GCF? What do you think of factoring out the GCF? Let's go back to that other one we looked at. Let's go back to this one then. So what's our GCF then? (5x to the 3rd). Good. So I don't know if you know this or not, but what you're doing when you undistribute is you're essentially dividing. We're going to be taking 5x to the 5th and dividing it by 5x cubed. Now, we're not going to do this division until chapter 8. But you should be able to figure it out if you expanded everything out. right? If you expand this out, the 5's cancel. X to the 5th, that's x over x cubed is x. These 3 cancel these 3. So what's that leave? X squared, okay. And then what? Remember, we're dividing. We're dividing negative 10 by 5. So that's going to be minus 2, and we have x to the 4th divided by x cubed. So that's going to leave a minus 2x. And then, oh man, 120 divided by 5. How many times does 5 go into 120? 24? Is that going to be plus 24 or minus 24? Minus. So, just when you think you're done, remember I talked about the directions? Suppose this particular problem, said factor out the GCF. If that's all it said, we'd be done. We'd be done. Factor out the GCF. We just factored out the GCF. Sometimes the directions are going to take it one step further. Sometimes the directions are going to take this one step further. And sometimes the directions are going to say, factor completely. Factor completely. Well, we factored out a GCF. What the heck are you talking about? I'll show you what I'm talking about. The GCF's there. But do you remember last week when I had you foiling and you ended up with trinomials for your answers? There's a reason I had you doing that. Because when we go the other way with it, guess what we're doing? You picking up what I'm putting down here? This is what factoring is all about. Factoring is unfoiling. Foiling is multiplying. Factoring is unfoiling, unmultiplying. So when we're looking at this expression, there's one of these numbers that we got to look at that we got to be able to find factors of to be able to factor this. Remember yesterday when I said to be able to factor, you got to find factors of a number? 24? So we have to be able to find 24's factors then. 24's factors that do something. That do something. Anybody remember what these things have to do? What they have to match up to? That's what we'll be talking about on tomorrow. Until we meet again. Shout out to the future Mr. Minnick for being such an awesome guy. Shout out to my 5th period class for being such an awesome 5th period class. Shout out to my 6th period class for watching videos 2 days in a row. Shout out to my 7th period class for watching videos 2 days in a row.